Everyone, welcome to the AnalogX. Today we will solve this numerical problem. So in this problem, we will use some standard steps to calculate gain. So this is very good numerical problem to practice. So let's read this question. They have given calculate short circuit GM of the circuit and then calculate output resistance and then calculate gain equal to GM into R out. So this is the standard steps to calculate gain. First we calculate short circuit GM and then R out, then multiply both and we get uh, gain of the circuit. Usually you don't feel these steps to good for the small circuits, but when you will solve the large circuit, then you will feel that this is very helpful. Okay, so let's solve this question. Okay, so first we will solve the short circuit GM. So to calculate short circuit GM, we know that first we will ground the supply voltage and all the independent voltages. So this will be small signal ground and this will be open circuit and this is my input voltage and just short circuit the output. Okay, and this will current will be I short circuit. So my GM short circuit will be short circuit current divided by input voltage. Okay, so this is my input and this is my short circuit current. I have to find the ratio. Okay, so what will be the this current? This current will be GM1 VGS. So gate voltage is input, V input, and source is this one is ground. Okay, so this will be GM1 main. Okay, and the same current will flow through this M2 transistor. Okay, so this current will be GM1 main. And how this diode connected transistor will offer a resistance? It will offer a 1 by GM2 resistance. Okay, so the drop across that 1 by GM2 will be this polarity. Okay, so what will the this voltage? This voltage will be V VSG2. Okay, VSG2 will be current, that is GM1 V in into resistance. Resistance is 1 by GM2 and this is also equal to VSG3. Okay, so they both are same. Now what will be the this current? This current will be ISD3. Okay, so whenever I will use VGS, I will use current as IDS, and when I will use VSG, I will say it's ISD. Okay, so this is for both PMOS and NMOS, so we don't get confused for signs. Okay, so what will be the ISD3? ISD3 will be GM3 into VSG3. So this one is GM3 and VSG3 is this one. Okay, so we will put this value. So that will be GM1 V in by GM2. Okay, so from here, what will be the this current is ISD3. Okay, so what will be the ISC? So short circuit current is this current. This current will be 0. Okay, and this one is short circuit, so this current will be also 0. There won't be any current through load resistance. Okay, so only this current and this current will add to the ISC. So ISC will be GM1 V in plus this current ISD3. So that will be GM3 into GM1 into V in divided by GM2. Okay, now I will take common GM1. So ISC equal to GM1. Okay, and this will be 1 plus GM3 divided by GM2 into V in. So what will be the short circuit GM? That will be ISC divided by input voltage, and that will be GM1 1 plus GM3 divided by GM2. Okay, so we solved the first problem. Okay, now in second case we have to solve output resistance. Okay, so let me draw the figure. So this is second question. So this is my PMOS, and this is my M2, and this one is M3, and this one is diode connected. This is my input transistor M1. This is my input, and this is my bias current of M1, and I'm taking a output here. Okay, load resistance. This is my Vout. Okay, so let me resize. Now I have to find R out. Okay, so for R out, we know that we will turn off all the independent sources, and I will small signal ground the input. Okay, and we will apply a test voltage here. Okay, and we will see how much current circuit will draw from this test voltage, and we will calculate from here. Okay, so now again this will be open circuit, so there will be no current here. Okay, so this will be 0 only. And then what will be the this current again? So if this voltage is Vt, this voltage is also Vt. So this current will be Gm on Vgs. So that will be Gm on Vgs1. Okay. So even IDS1. Okay. So that will be Gm on Vg was 1. Okay. So that will be Gm on Vg is 0. Source voltage is Vt. Okay. So that is Gm on minus Gm on Vt. So it's flowing upside, that is it will be Gm1 Vt. Okay, IDS is minus Gm1 Vt, so ISD will be Gm1 Vt. Now this current will flow through this. Okay, so again now this drop will be like this. So what is this voltage? This voltage is VGS2. So that will be current Gm1 Vt into resistance, that is 1 by Gm2, and this is equal to VGS3 also. Okay, so this voltage is VGS3. Now what will be the IDS3? So again I'm taking drain to source, so I will take VGS3. Okay, into this one GM3. Okay, so this current IDS3. So this will be GM3 and this value. Okay, so this will be GM1 VT into 1 by GM2. Okay, so this one, let's I say, okay, so there are total this one current, one, this one, two, and there is this one third current. Okay, so what will be the total IT? Total IT will be IS IDS3 plus VT by RL and plus IDS3 plus VT by RL, and this one GM1 VT. Okay, GM1 VT. Now put all the value. IDS3 is GM3 GM1 divided by GM2 VT plus VT by RL plus GM1 VT. Now we will take common GM1. So first let common VT, so that will be GM1 plus GM1 GM3 divided by GM2 plus 1 by RL. So what will be the R out? R out will be VT by IT. So that will come as 1 by GM1. Let me common this. So 1 plus GM3 by GM2 plus 1 by RL. Okay. Now what will be the gain? the finally the gain will be AV equal to GM into R out. Okay, so GM is GM1 and 1 plus GM3 by GM2. Okay, so GM is GM1 1 plus GM3 by GM2. Okay, and R out is this one. So R out will be GM1 1 plus GM3 into GM2 and plus this one is GL. Okay, so that is our gain of this circuit. Okay, so this is how we solve any gain question. So first we calculate short circuit GM and then we calculate R out and then we multiply both. Okay, so you can practice this question. This is very standard approach to solve. Okay, please let me know if you see any wrong thing. Okay, so okay, thank you. Bye. I will come with another good question. Or you can also comment you know any questions or any references, so I can refer that also. Okay. Okay. Thank you. Bye.